Modernage MCQs, Physics second year, unit number 17, Electronics, Part 1. At room temperature, a small current flow through an intrinsic semiconductor is detected. The current is due to a fictitious particle known as option A, meson, option B, photon, option C, boson, option D, hole. The key is hole. The option D is correct. Reason. At room temperature, the bond of semiconductor breaks, the electron becomes free, and electron deficiency in the bond behaves like a fictitious particle known as hole. Hence, the current is due to a fictitious particle known as hole. The hole created by the break of a covalent bond as apparent charge and mass. Option A plus 1.6 into 10 power minus 19 coulomb and 1.67 into 10 power minus 31 kg. Option B minus 1.6 into 10 power minus 19 coulomb and 1.67 into 10 power minus 27 kg. C plus 1.6 into 10 power minus 19 coulomb and 9.11 into 10 power minus 31 kg. Option D minus 1.6 into 10 power minus 19 coulomb and 9.11 into 10 power minus 27 kg. The key is plus 1.6 into 10 power minus 19 coulomb and 9.11 into 10 power minus 31 kg. Therefore, the correct option is C. Reason. Hole is the deficiency of electron in covalent bond. It is completed only with an electron. Therefore, the hole created by the break of a covalent bond as apparent charge plus 1.6 into 10 power minus 19 coulomb and mass for 9.11 into 10 power minus 31 kg. Hence, the apparent charge and mass of hole is plus 1.6 into 10 power minus 19 coulomb and 9.11 into 10 power minus 31 kilogram. In a crystal of germanium, tightly bound electrons in the outermost orbit of each atom are option A 6, option B 10, option C 14, option D 18. The key is 18. Therefore, the correct option is D. Reason. Each atom of germanium contains 32 electrons distributed in orbits as 2, 8, 18, and 4. Hence, force valence electrons share themselves in covalent bonds, and the tightly bound electrons in the outermost orbit, third orbit, of each atom are 18. Hence, the tightly bound electrons in outermost orbit are 18. In a crystal of silicon, each atom shares option A, one electron in covalent bonds, option B, two electrons in covalent bonds, option C, three electrons in covalent bonds, option D, four electrons in covalent bonds. The key is four electrons in covalent bonds. Therefore, the correct option is D. Reason. In a crystal of silicon, each atom shares 4 electrons in covalent bonds with other atoms. Hence, each atom shares 4 electrons in covalent bonds. In a crystal of silicon, the tightly bound electrons in the outermost orbit of each atom are option A 8, option B 6, option C 4, option D 2. The key is 8. Therefore, correct option is A. Reason. Each atom of silicon contains 14 electrons distributed in orbits as 2, 8, 4. The 4 valence electrons share in covalent bonds. Therefore, tightly bound electrons in the outermost orbit, which is second orbit of each atom, is 8. Hence, the tightly bound electrons in the outermost orbit of each atom are 8. The ratio of atomic numbers of silicon to germanium is option A 7 to 8, option B 7 to 11, option C 7 to 13, option D 7 to 16. The key is 7 to 16. Therefore, the correct option is D. Reason: the atomic number of silicon is 14 and germanium is 32. Therefore, silicon to germanium ratio is equal to 14 to 32, which can be written as 7 to 16. Hence, the ratio of atomic numbers of silicon to germanium is 7 to 16. A semiconductor is converted into N-type material if it is doped with option A pentavalent elements, option B tetravalent elements, option C trivalent elements, option D divalent elements. The key is pentavalent elements. Therefore, the correct option is A. Reason: the N-type semiconductor carries free electrons in the conduction band. When a pentavalent element is doped in semiconductor, 4 electrons share in making covalent bonds. One remains free in the conduction band. Hence, a semiconductor is converted into N-type material if it is doped with the pentavalent elements. A semiconductor is converted into P-type material if it is doped with option A pentavalent elements, B tetravalent elements, C trivalent elements, D divalent elements. The key is trivalent elements. Therefore, the correct option is C. Reason: the p-type semiconductor carries 3 holes, apparently behaving like positive electron. When a trivalent element is doped in semiconductor, 3 electrons share in making covalent bonds with atoms of semiconductor and one bond remains incomplete. This incomplete bond is called hole. It behaves like positron and semiconductor is said to be p-type. Hence, a semiconductor is converted into p-type material if it is doped with the trivalent elements.